The other announcement is that the university, the official policy of the university is that after reading week, we are back in person, which means I will be lecturing from a lecture hall. So the lectures will move from Teams to some other to in person. But I don't plan on changing the delivery of the course at all. So that means if you're watching the videos, if you want to attend the lecture virtually, there will still be a way to do so. It'll either be a Teams meeting of some kind, or it'll be using the live stream facilities provided by the university. Similarly, your midterm is online because that's what it says on the syllabus. And your exam is also on OnQ because that's what it says in the announcements on OnQ, right? So the delivery of the course isn't changing. I will be in the lecture hall though, assuming we're still coming back. The university still might change its mind. But assuming that we're coming back after reading week, there will be in-person lectures. All right, the labs will stay online because it's just too awkward to move them now. All right, so let's continue with our lecture. Rid of that. So in the previous lecture, we were talking about using objects. Now, normally when when you're using objects, the way you use an object is you normally call a method on it. Sometimes you can access the information in an object directly. So in your assignment 1, you're actually creating you're using a simple object, and you're accessing the information in that object directly. So to access a method that belongs to an object, right? So a non-static method, you use a variable that refers to an object, dot, and then you call a method on that object. If you have an object where you can access information, I'm just going to duplicate this slide very quickly. So using an object usually means, okay, so this is going to be sometimes. Sometimes means accessing information belonging to the object using the object. So there will be variable. What do we want this? We want to call this an object field. Okay. Right. So objects also have information. The information is just basically it's a variable that belongs to the object. So those variables are called fields. Right. If an object has a publicly available field, then you can access the field just by using the name of a variable that refers to the object, then dot field name. So you'll be doing that in assignment 1 in a few places. Where's the, sorry. Okay. So this is the example I went over in the at the end of the last lecture. So this is using our points2 class, which represents a two-dimensional point. Right? If you want to call a method using on the point, if you want to call a method on a point2 object, right? Here we've got an object referred to by the variable p, right? Use the variable name dot method name, right? So x and y, these are two methods that return the x and y coordinates of the point. Class also defines methods with the same name, so x and y, but they change the coordinates of the point. Right? And similarly, there's another method called set that lets you change both coordinates of the point. So if I do p set xy and then print p, the coordinates of the point will no longer be 0.5 and 0.1, right? Because x is 0.6 and y is 0. So if I call p set xy and then print the point, it'll be the point you'll get is it'll print out 0.6 and 0 for the coordinates of the point. A slightly more complicated example. It's not a lot more complicated. It's slightly more complicated. I'm going to make a point. Right. It's going to start at 0.5 and 0.5. Right. So that's its starting coordinates. I've got a variable called radius. Now this is we haven't seen this before. So this is a final variable. So in Java, the keyword final, when you apply it to a variable name, or when you apply it to a variable, means that you can only give the variable a value once. Right? So you can only give it a value once. You don't have to assign it here. Right? If you assign it here, or if you initialize it here, right, then I can no longer change that value. Right? So in other words, radius always has the value 0.1 in this example. Example, radius is a constant. If you create a constant in Java, you're allowed to give it, by convention, you can write the name in all caps if you want to. You don't have to, but it's common to see it written in all caps to indicate that it's a constant. Now, one thing I should point out is that this is radius is a constant only because it's a primitive type. So because radius is primitive, it stores the value 0.1, right? Final means I can only assign the value once. So in this case, it means radius always has the value 0.1. I tried to create a final variable of type 0.2. Imagine I wrote final 0.2 and then big P, big O, big I, big NT, right? So point, and then equals some point, right? That's not actually a constant because the point class, the 0.2 class, has methods that let you change the coordinates of the point, right? So let me just write that in. To, let's call it the origin. Equals 2.2. Something like that. So if I write something like that, semicolon, right? This looks like it point. Sorry. 2.2 like that. That's what I want. Okay. So if I try to write something like this, right, then the name origin looks like a constant, right? So to a Java programmer, they'll say, oh, this thing origin, I can't change it, right? I can't change it. But that's not true because you can write origin dot. Question in a minute, Noah. So I can still use the variable origin to call the methods, to call a method like set, right? So in other words, I can change the coordinates of the point referred to by origin by calling a method, right? So for example, I can set the coordinates of the point to be something like 100, 100, right? And that doesn't make sense anymore because 100, 100 is not the origin, right? So if you have when you apply the keyword final to a reference type, not necessarily a constant, so you have to be careful about that. In other words, in this case, you probably shouldn't do this. It's deceiving to the user or to the reader, right? This thing that's called the origin isn't really always the origin, or isn't necessarily always the origin. So be careful when you do that. If it's a primitive type, no problem. It's always constant. If it's not a primitive type, you have to be a little bit careful about it. Now, what happens if you apply final to a method? So you can apply the keyword final to a method, but it doesn't mean what you think it means at this point in time. So it does not mean you cannot change any of the fields in the method in the object. If you make a final method, what that means is that you cannot change the definition of the method. Now you might say, well, that's weird because you can't change the definition of a method anyway. But that's not exactly true in Java or in most object-oriented programming languages. So you'll see later on in the course, probably 4 or 5 weeks, maybe a little longer from now, an object-oriented programming languages let you have a mechanism called inheritance. So you can create a class by inheriting from another class. So in Java, it calls it extending another class. Now, when you extend another class, you get all of the methods from the class that you're extending. And in your new class, you're allowed to change the definition of those methods. So if you mark a method as being final, any class that extends your class can no longer change the definition of that method. So it means something slightly different. But we're not ready for that yet. Okay, let's carry on with this example. So I've got this variable called dx. And you'll see what I'm using that for in just a moment. And then I have an infinite loop. Right? So while true, so this is an infinite loop. Right? It looks like I'm going to change the x coordinate. I'm going to use the x coordinate of the point. Right? And I'm going to add this small constant dx to it. Check. If x is bigger than 1 minus the radius, right? Apparently, I'm at the right edge of this window here. So you'll see what I mean by that in a second, right? So I'm going to set x equal to 1 minus the radius. So this is as far right as I want to go. And then I'm going to change the sign of dx. Now, if I'm on the left edge of the window, right, I can do the same thing, right? I'm going to change the sign of dx. Right, so dx is the direction that this point is going to be moving in, right? So it starts by moving right, and then it's going to move left, and then it's going to move right, and then it's going to move left, and then it's going to move right, and so on and so on and so on, right? I'm going to update the coordinates of the point, right, using my method x, and then I'm going to draw a circle using this class called standard draw. Standard draw, the name is a little misleading. It's not actually a standard Java class. So I'll tell you exactly what that is in a moment. Let me flip over to Eclipse. Too many windows. Here we go. So again, let me change the font. So please bear with me. This is actually a little. So when I'm working in Eclipse, I normally work in this size of a font, but I know that if you're looking at this for the internet, you may have a hard time reading it. So I have to flip back and forth. That. Okay, so there's our class. Right, it's the exact same thing that I just showed you on the slide. If you run this, you get the following. So there's your bouncing ball. Right, so it's just a ball that moves back and forth using the points2 class. Now, this standard draw class, you might wonder where it comes from. It actually comes from there's a Java book that's written by some people at Princeton University in New Jersey. It hasn't been updated in a while, so that book is quite old now. But it came with that book has a class called Standard Draw that lets you do some simple drawing stuff, like draw very simple graphics primitives, like circles and squares and things like that. You'll see it in assignment 1, because that's what I use in assignment 1 to draw a picture of the thing that you're computing in assignment 1. If you've downloaded the course notes, so there's a zip file that's in the course notes that includes all of the source code for the course. Here it's called Sys124, but that's just because I'm using last year's version of it. You'll have your notes are called CMPE 212, CMPE 212. You can find the standard draw class in those notes. So you'll see that there's a package called Princeton Intro CS, and in there you'll find the standard draw class. Right? It's also in assignment 1. Right? You also get all of this other source code that's sitting here, almost all of this source code. So all the source code that's in the notes you have access to via the zip file that you may have downloaded already. It's also available on the GitHub for the course. So if you just want to look there, you can get it from there as well. Oh, there's a more complicated example. Sorry. Should close some of these windows. Okay, here we go. This one's a slightly more complicated example. I don't want to look at the whole thing, right? Because it's quite a bit more. It's a bit more sophisticated. But you can do something like the following as well. Right, so you can basically take that Pong program I just showed you and change it into a bouncing ball program. So here I'm using some very simple physics, right? So this is the stuff you would have learned in first year physics to compute the motion or the kinematics of a simple projectile, right? So a free body that's under the influence of gravity only. and I'm having it bounce around the screen like this. Right. Again, that's also available to you in the course notes. Inside, I think I tell you where. Yeah, so if you look here, that's CMPE 212 for you. Oh, wait, did I change? I don't know if I changed this package name. I probably didn't. So it's probably CISC 124. I didn't change it because there's too many packages to change. Maybe next year. But you have access to that source code there if you want to play around with that. Is the use of Eclipse? No, it's not mandatory. You can use whatever IDE you want, but all of the stuff that I provide assumes Eclipse, right? So if I have so when I give you a project archive, it's an Eclipse project archive. If your IDE can read an Eclipse project archive, then go nuts, right? Otherwise, you have to deal with the problem of importing or extracting the content from the archive into your IDE. Which is the line of code that shows the ball where the window? Ah, yes. So the window, the ball. I think you mean the bouncing ball, Lee. Is it the bouncing ball? The one that goes back and forth is pretty straightforward, right? So what you need to know about this standard draw class, if you don't do anything special, and I'm not doing anything special here, then the standard draw class creates a window. Its left edge is, what is it? It's 0. So the x coordinate of the left edge is 0. The x coordinate of the right edge is 1. The y coordinate of the top edge is 1, and the y coordinate of the bottom edge is 1. 0. You can change that if you want to, which might actually happen. I don't remember how this one works. Okay, so in the bouncing ball, apparently the left and right edges are 0 and 20. And the ground would be y equals 0. Okay. So in the bouncing ball one's a little bit more sophisticated. So where do I check for the action performed? So you want to look in that method to see how it adjusts how it detects whether or not. Oh, actually, it's right here. So if the position of the ball, if its y coordinate is less than 0, it reverses the velocity vector. If the x coordinate of the ball is less than 0, or if the if the x coordinate of the ball is greater than 20, then it reverses the x component of the velocity. Right. So here the velocity is represented as a vector, as a two-dimensional vector. Okay. Let's see. Here's an example of using a scanner object to read input from the user. Again, so I mentioned this in the last lecture. I don't like giving examples like this because it gets a lot of students get into the mindset that you always get input like this, right? And so in other words, I'll ask someone to write a method that has an input parameter of some type. And then inside the method, the student will create a scanner and then try to read in the value of that parameter. So I really dislike using reading the keyboard for input in a program. But if you want to do it, this is how you can do it. Right. So the scanner, that's the object that will scan a stream of data. So system.in, that's just standard input. In other words, that's your keyboard on most computers. Right. So you can create a scanner object that will scan your keyboard for input. Right. The scanner object has a method called hasNextLine. Right. So that's just a method that checks if the user has typed in something and pressed enter. Right. If that value is true, right, or while that value is true, it will actually it'll read that line using the next line method, right, and then it will and then it'll simply print the line that was typed in. Sorry, it'll simply print the line that was typed in. hasNextLine actually always returns true if it's connected to the keyboard, right? Because it's possible that the user simply hasn't typed something in yet and pressed enter. So I'm pretty sure this always returns true. So in other words, this loop basically runs forever until you kill the program. or type in Control C on most keyboards. Oh, yeah, right. Okay, so if you want to be a little bit more sophisticated, right, you can actually check what did the user type in, right? So you can get the input as a string, and then check, is the string equal to quit, right? And if they type quit, you can break out of this loop, right? So that's a little bit more, that's a little nicer to use. Right. So I guess the natural question to ask is, if classes have all of this, if classes provide all of this functionality, how do you know what the functionality is? And the answer is, you look at the documentation, right? So if you hit that link, you can find the documentation for version 8 of the language. You don't want to use version 8 of the language. So basically everything we do in this course is available to you in version 8 of the language and up. The current version of the language, I believe, is 17, but that's because the company that's in charge of the Java standard has committed to 6-month updates of the language. So every 6 months, something happens to the language, which means they're churning out new versions of the language all the time. Turns out that the previous several versions of the language, there haven't been any significant, there haven't been any really big additions to the language. So if you look at the version of the documentation for Java 8 or higher, you're fine. Another way to do this is to just use your search engine to search for documentation for a class, right? You all know this. Typically, this takes you to Stack Overflow or some other site like that, where people will chime in on how to do X, Y, or Z. Let's see. Again, if you've downloaded the course notes, you can access the documentation for all of the notebook classes. So if you pop open if you've got your course notes and you can see all of these packages, somewhere there's a folder down here called doc, right? If you find the location of this directory, you can point a web browser to index.html, or you can just click index that file there, and there is all the documentation for the classes. There's documentation for almost every class that's in the course notes. So, for example, if you look at the no, not here. Sorry. How do I go back? I never use the Eclipse web browser, so I'm actually not sure how to go back. Does that work? Maybe here. Okay. I'm looking for the point 2 class. Here we go. So if you want to see the documentation for the point 2 class, there it is. Right, and you can. It's actually got quite a lot of methods in it. So there's quite a few, but it's all available to you there. Reading an API example. I think I've done this before. So I think we've gone through looking at an API before. Does this work? Oh, this works. Hey, look at that. So I guess let's look at the point 2 API. So this, the API is short for Application Program Interface for a class. That simply means the documentation for the class. So when you open up the API for a class, you'll see something like this. Right at the top is it tells you what package the class is defined in, tells you the name of the class. This right here is the inheritance hierarchy for the class. Right. So I'm just going to point this out now. It probably won't mean much to you at the moment. But what this is saying is that the class point 2 inherits or extends from this class called object, right, which is defined in the package java.lang. Right. It turns out that in Java, all classes inherit from this thing called object. Right. So in other words, in Java, all of your object references are also references to this type right here. Right. So another way to put that is a point 2 object is also a big O object. Right. Now this turns out to be significant in Java. Can I open another? I can. Let's try this. Oh, hey, look, that works. All right. So that turns out to be, yeah, whatever. I don't know why it's going. Okay, doesn't matter. This turns out to be significant in Java because the class object, it even tells you it's the root class of a class hierarchy, whatever that means, right? Because the class object actually has some important methods in it. So it's got a method like called toString. And toString says that it returns a string representation of the object. And so what that means is if you have a variable that points to an object, right, you can always use that variable to call toString, right? And that will give you back a string representation of the object. Right? So if you call it on point, excuse me, if you call it on point 2, wait, how come I can't go to my other window? If you call it on point 2, where's toString for point 2? Here, right? Then that gives you a string representation of the point where you get the coordinates of the point separated by a comma and a space, all inside a pair of parentheses. Right. So here's an example of where the point2 class has replaced the definition of toString so that it produces a nice string for a point2 object. Right. And this is actually the way that Java does a lot of things. So it defines a bunch of methods in point2. How do I get that window back? Probably gonna have to close it. Yeah, here we go. All right. So where is this object? Where did object get to? Man. All right. This is the reason why I never use the this is one of the reasons why I never use the Eclipse built-in web browser. Java 8. Here we go. Okay. So not only does object define toString, it defines a bunch of other methods as well, in particular equals, right? So remember I told you that if you want to compare two reference types, you should always use the equals method, right? So what that means is every class, right, needs to have an equals method of some kind. Right? Now equals is defined in the class big O object, right? And that means every class already has a definition of equals, right? So that's what lets you always call the equals method on any object. So you can always call equals, you can always call toString, right? For our purposes, these are the only two interesting methods. The other ones are related to other topics that are beyond the scope of this course. There is one other one that we'll talk about later. Hash code is another one, but we'll talk about that later. So that's the equals method. I guess that's what else is in point 2. So the next part in the documentation, you'll see a brief description. Well, not necessarily brief description. You'll see a description of the class, right? So this one simply tells you that a point 2 is just a two-dimensional point, right? Then the next section is the constructor summary, right? If you click on one of these, it'll take you to the extended documentation, right? So if I click on this one, it takes you down to here, right? And when you look at the detailed documentation, right? In the detailed documentation, you'll see a description of what the parameters are, right? So my constructor point 2 has two parameters called x and y. What's x? Well, x is going to be the x value of the point, right? And y is going to be the y value of the point, right? What does the constructor do? It initializes the coordinates of the point to x, y, right? Where x and y are specified by the caller. Scroll back up. Past the constructor summary is the method summary, right? So here you can see methods. Some of them are static, right? So, if it's a static method, remember you use the class name to call the method. Some of them are not, right? So add is not this version of add is not a static method. Anything in blue you can click on, right? So apparently there's another class called vector2, right? Which works with the point2 class. Right? So I can take a point and I can add a vector to the point, right? Changing the coordinates of that point. Right? If you want to know what the vector2 class does, you just click on vector2. right? And it'll take you to the vector2 documentation. Right? And then there's a whole bunch of other methods as well. So that's the basics of reading an API. There's also a notebook and a video that talk about reading an API. We're done with this one, right? Yeah, we're done with that. Okay, so objects. Good. Right. So that's the basics of using objects. I guess the important parts in this lecture were how do you make an object? Well, you use new, right? In conjunction with a constructor. Okay. So the purpose of a constructor is to initialize the state of an object. Right? That's important in Java because you never want to create an object that's in an invalid state. Right? So constructors typically will test their argument values, the argument values supplied by the caller, to make sure that the caller is providing the constructor with reasonable values. In Java, you don't normally worry about the destruction of an object, right? So normally you don't worry about cleaning up after an object when you're done with the object, except in certain special cases. Right? However, you never worry about freeing the memory associated with an object, right? The language takes care of that for you. Objects can have information, right? In the form of fields, which are just variables that belong to the object. And objects have behavior, which are just methods. Right? To call a non-static method, you use a variable, then a dot, and then the name of the method. API, so documentation. So Java is, I guess it's the first major language that standardized the way its documentation should look like, and it also standardized how you should access that documentation. Right. So in Java, the documentation is always accessed through a web browser of some kind, or it's available as HTML. Right. So anything that can read HTML can read Java documentation. A Java API always looks the same. There are minor changes from the version for the language versions, right? So if you look at the documentation for version 9, it looks cosmetically different than the documentation for version 8, right? So occasionally they make small updates to the CSS for the HTML for the web page, but the layout of the document is always the same. All right. So the next lecture. Well, it's about lists in Java. Now, I think most of you have taken the data structures course, so you've seen a list before. You haven't quite seen a Java list. Oh, sorry, I should change that to something else for this course. So I'm guessing, so I don't know what you do in your data structures course, but I'm guessing you've seen a linked list. That's my guess. Hands up if you have also seen an array-based list. So did you make a list in C where the elements were stored in an array? Yes? Few people say yes. Okay, so that's good. And am I correct that you also did a linked list? So hands up if you used a linked list or implemented the linked list. Let's see. Super. That's actually really good. Okay, that's nice. Okay, so if you want to use a list, so a list has a lot of advantages over a plain array. As in C, right? If you have a plain old array, you're stuck, right? If you can't resize the array, right? If you are in the situation where you have to resize the array, right, then that involves making a new array, right? Either using malloc or realloc. I guess you could use calloc, and then copying the elements from the old array into the new array, right? Which you have to do manually in C. And there's a bunch of other things you can't easily do in C, right? So you can't easily get a sublist in C. You can't, if you want to check if two lists are equal, right? In other words, do they contain the same elements in the same order? right? You have to write your own function to do so, and so on and so on and so on, right? So because lists are um, very because you often want the functionality of a list in a program, the Java standard library provides you with two major list implementations. Right? There's actually more than two, but there's two major ones. The one you normally use in Java is ArrayList. There is also a linked list class. Right? So there's another class called Big L linked, Big L list. Right? So ArrayList corresponds to the array-based list that you learned in your data structures course. Linked list corresponds to the linked list data structure that you learned in your data structures course. I really should change. Okay. Ignore this first line because that's not important to you. So in Java, when you make a list, the list can store elements of a single type. Right? That's not exactly true. For the time being, that's just take that to be true. Right? So in other words, I can make a list that can hold a bunch of ints. Well, not quite ints, but I can make a list that holds a bunch of integers. I can make a list that holds a bunch of doubles. I can make a list that holds a bunch of strings. And I can make a list that holds a bunch of points. Right? But there's no way for me to make a list that can hold a point and a string and a double at the same time. Right? Again, that's not exactly true, but for now, take that to be true. Right? So when you use a Java list, you have to tell the compiler what the element type is. Right? So the way you do that is you use this funny less than, greater than, and stick the element type in between. And so you only use this notation when you're working with what are called generic classes in Java. Right? So in Java, if I want to make an array list that can hold a bunch of strings, then your type, right, is array list less than string greater than. Right? So that thing there in the diamond, it's called the diamond notation, right? So the thing there is the element type of the list. I'm going to make an array list of string called T, right? How do I make that list? Well, I use the new operator. I call a constructor, right? So for the constructor, it's array list less than string greater than round bracket, round bracket. Now, if you're using any modern version of Java, you can get rid of that on the right-hand side. You can simply say new array list and then less than, greater than. You don't need the type here because the compiler can infer the type from the thing on the left-hand side. So that's a little easier to write. That makes me a new empty array list, right? So that's an array list that has 0 strings in it. Now, there's a problem in Java in that you would really like, there's a lot of cases where you would really like to make an array list of int, for example, or an array list of little d double, right? Or that's not supposed to be there. Or an array list of Boolean or something like that. Right? Unfortunately, you can't do that in Java. And the reason you can't do that in Java is because the ability to make a class like ArrayList where you can specify the element type, that wasn't added to the language until the language was somewhat mature. Right? So in version 5 of the language, this ability to create a type like ArrayList where you can specify the element type, that didn't show up until Java 5. And the way that they added the mechanism prevents you from being able to create an array list of int, for example, right? So you cannot use a primitive type here, right? It's inconvenient, right? So the problem, if you can't make an array list of int, then how on earth do you make a list that can hold a bunch of int values? Right? So that's one of the problems that the designers of the language have to deal with. Right? So the answer is they made a bunch of classes called the wrapper classes. Okay? So every primitive type has a corresponding reference type, which is called its wrapper class. Right? So the primitive type Boolean has a corresponding type big B Boolean. Okay? Primitive type little b byte, has the wrapper type big B byte. Now, the wrapper classes normally are the same name as the primitive type, except for character. Okay? So the wrapper class for car is called character, big C character, and the wrapper class for int is called big I integer. Okay? And you've actually seen that wrapper class before, and you've seen that wrapper class before. Remember, to get the largest or most negative int value, you can use big I integer dot max value and big I integer dot min value. Right? So it turns out those constants are defined in that class right there. The wrapper classes define a bunch of constants and some methods that are useful or that are related to the corresponding primitive type. Why are they called wrapper classes? Because because the wrapper class for int, which is integer, right, can automatically convert between these two. The compiler can automatically convert between these two. So if there's a case where you have an int, but you actually need a big I integer, then the compiler can automatically convert the int to big I integer. So we say that the compiler can wrap the primitive to produce an object that corresponds to whatever value belongs to that int. Similarly, the compiler can go the other way. If you have a big I integer object, right, and you want to do something with it that requires an int, right? So for example, suppose I want to add two integer values together. The compiler can take that wrapped class and give you back the primitive type automatically. So you can add two big I integer objects together. So the compiler unwraps the integer object to give you back the int value. Right? This all happens automatically, so you normally don't have to worry about it. So the wrapper classes are special, right? So they're similar to string in that the compiler will treat them somewhat specially. So in particular, the compiler will try to convert between a primitive value, between a wrapped value. Oh, sorry, we'll try to convert a value from its primitive type and its wrapper class, and vice versa when required. Right? So for example, I can make the int variable I, set its value to 1. If I want to, I can make a big I integer object called j and set its value to I. That's fine. Right? So it'll automatically wrap I to produce an integer object and then store a reference to that object in the variable j. Similarly, I can take j, right? Now remember that points to a big I integer object, and I can store that in a primitive type k, right? What actually happens here is that the object that's pointed to by j, right, it gets unwrapped, and all that means is it takes the int value of j and stores that in k, right? This all happens seamlessly. Now, you should avoid doing this if you can, right? So don't write code like this if you don't have to. Sometimes you have to, but don't avoid writing code like this because the wrapping and unwrapping process takes some time in memory, right? It's not a lot of time and not a lot of memory, right? But if you just want an int j, don't make an object, right? Because that's unnecessarily using memory and time. It's much faster to use a plain old int if you can. Right? Now, if you want a list of int though, you have to use the wrapper classes, right? So if I want a list of int, then you make an array list of integer, big I integer. If you want a list of double, then you make an array list of big D double, right? If you want a list of car, then you make an array list of big C character, right? When you put things or take things out of the list, you can put the primitive types into the list. Compiler automatically wraps the primitive types and puts them in. Right? When you take things out and you use them as the primitive type, the compiler takes something out of the list, automatically unwraps it, and gives you back the primitive type. Right? So that all happens seamlessly. but there is a small performance penalty associated with the generic facility in Java. Oh, this is really not relevant to you guys. Okay, so this is a good place to stop. Let me redo that slide and pick this up next lecture. So I'm just gonna, this is relevant because you guys haven't learned Python. So I'm going to show you how to use these methods in the next lecture. Anybody have any questions for me about today's lecture? All right, I'm not seeing any. Yeah, I'm not seeing any. So I'll end things here and see you tomorrow.